In this episode, we're going to zoom in on building automation and the networks that make modern buildings feel smart, because these environments sit right on the boundary between OT and everyday life. Building systems control heating, ventilation, and air conditioning, lighting, access control integrations, elevators, safety-related monitoring, and sometimes energy management, and those systems are often distributed across a facility in ways that create unique communication patterns. Beginners sometimes think building automation is less serious than industrial plants, but buildings can be critical infrastructure in their own right, especially in hospitals, data centers, government facilities, and large commercial campuses. The networks that support building automation can include protocols like BACnet and KNX, and you will also see Profinet in mixed environments where building systems and industrial systems overlap or share concepts. The goal is not to turn you into a building engineer, but to help you recognize what these protocols are generally used for, what risks and constraints they introduce, and how mixed environments can create unexpected pathways. Mixed environments are common because buildings are rarely isolated from business networks, and because vendors and contractors often need access for maintenance. If you can reason about building automation networks with the same seriousness and clarity you apply to other OT networks, you will be able to interpret exam scenarios that involve facilities, smart building devices, and cross-domain connectivity. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful starting point is to understand what makes building automation different from many industrial control settings, because the priorities and operational rhythms can be distinct. Many building systems are designed to support occupant comfort, energy efficiency, and basic safety monitoring, and they often operate on predictable daily schedules rather than continuous high-speed production loops. That means the timing requirements can be different, with less focus on microsecond-level determinism and more focus on reliable control over minutes and hours. However, the consequences of failure can still be significant, especially when building systems support critical functions like maintaining medical environments, protecting sensitive equipment, or ensuring safe evacuation. Another difference is that building automation often involves many devices spread across floors and rooms, like thermostats, controllers, dampers, and sensors, which creates a large device inventory and many physical access points. Those access points include closets, ceilings, mechanical rooms, and tenant spaces, which can make physical security more challenging than in a single locked industrial cabinet. Building automation also often involves long-lived devices and vendor-specific ecosystems, which can make patching and upgrades slow. From a security perspective, these characteristics mean that building automation networks can become a quiet source of risk if they are treated as facility stuff rather than as operational control systems. Beginners should learn that the physical process in a building is still a process, and controlling that process still involves trust, communication, and safe boundaries. BACnet is one of the most common building automation communication standards, and the beginner-friendly way to think about it is as a shared language that allows building devices and systems to exchange control and monitoring information. BACnet often supports interoperability between devices like controllers, sensors, and building management systems, enabling a central view of conditions like temperatures, airflow, and equipment status. The name shows up because buildings often use equipment from different manufacturers, and a common standard helps integrate those pieces into one managed system. From a functional standpoint, BACnet helps systems read values, write commands, and exchange events and alarms in ways that support coordinated building control. From a security standpoint, BACnet's history matters because early design assumptions often lean toward trusted internal networks, and many real-world deployments still rely on network placement and physical access control rather than strong built-in protections. That means if BACnet traffic is exposed to broader networks, or if unauthorized devices can join, the system can be vulnerable to unauthorized control actions or to manipulation of monitoring values. Beginners should also understand that building systems can include remote access pathways for maintenance, And if those pathways intersect with BACnet networks, trust boundaries can become fuzzy. Recognizing BACnet in an exam scenario should prompt you to think about interoperability and the need for careful segmentation, rather than assuming that the building system is safely isolated. KNX is another building automation standard that you may encounter, and it is often associated with distributed control for things like lighting, shading, and building functions that span many rooms and zones. The beginner takeaway is that KNX supports communication between many devices in a building, enabling coordinated behaviors like adjusting lights and blinds based on schedules, occupancy, or environmental conditions. Like other building standards, KNX exists because buildings are complex and vendors need a way to integrate devices into a coherent system. In practice, KNX deployments can involve many endpoints and long life cycles, and they can be managed by specialized integrators who understand the building's design. From a security perspective, the large number of endpoints and the physical distribution of devices can create exposure, because more endpoints means more places where a misconfiguration, a vulnerable device, or a physical tap could exist. Another important consideration is that building automation devices can be placed in publicly accessible or semi-accessible spaces, which increases the risk of unauthorized interaction compared to devices in secured industrial areas. Beginners should also understand that KNX, like many OT-related standards, can be deployed in ways that are very secure or very loose, depending on how access and segmentation are handled. The protocol name alone does not guarantee security. The design and governance around it do. When you see KNX mentioned, think about distributed building control, a large device footprint, and the importance of controlling both physical and network access. Profinet can appear in mixed environments because it is an industrial Ethernet-based communication approach that is used in automation settings, and it can be present in facilities where industrial processes and building systems intersect. A beginner might ask why an industrial protocol would show up in buildings, and the answer often lies in the fact that some facilities include industrial-style automation for things like energy management, specialized mechanical systems, or integrated manufacturing spaces within a larger campus. Profinet is often associated with automation networks that require reliable communication and structured device coordination, and in mixed environments it may be used alongside building protocols when certain equipment packages come from industrial automation vendors. The practical implication is that a facility might have multiple OT-style networks with different protocols, and those networks might be bridged through supervisory systems, shared infrastructure, or maintenance practices. From a security perspective, bridging creates the central challenge, because a bridge can allow issues from one domain to influence another. If a building network connects to an industrial automation segment, a compromise in a less protected area could become a path into a more sensitive one. Beginners should learn that mixed environments are not unusual, especially in large enterprises, and that protocol diversity increases complexity, which increases the need for clear boundaries and documentation. Recognizing Profinet in a building context should prompt you to consider that the environment may have industrial-grade automation components and therefore potentially higher consequences for disruption. Mixed environments also create operational challenges that shape how security must be applied. Facilities teams, OT teams, and IT teams may all be involved, each with different priorities and different vocabulary, and unclear responsibilities can lead to gaps. For example, a facilities group might prioritize occupant comfort and energy efficiency, while an OT group might prioritize process stability, and an IT group might prioritize enterprise security policy compliance. If these priorities collide without coordination, security measures can be applied in ways that disrupt operations, or operational shortcuts can be taken that weaken security. A building automation contractor might need remote access to troubleshoot a system, and that access might be granted quickly without full review because the building is uncomfortable or because a critical system is down. Over time, temporary access can become permanent, and permanent access can become an unmanaged pathway into the environment. Another challenge is that building systems often integrate with business systems for monitoring and reporting, which can lead to network paths that were created for convenience rather than security. Beginners should see that mixed environments require governance, meaning clear decisions about who owns what, who approves what, and how changes are tracked. The exam often tests this by presenting scenarios where the technical solution is less important than establishing safe boundaries and controlled access. One of the most important risks in building automation is that the same network can carry both monitoring and control actions can have real consequences even if they are not as dramatic as stopping a production line. If an attacker or mistake turns off HVAC in a data center, equipment could overheat and cause significant downtime. If ventilation controls are manipulated in a hospital or laboratory, the consequences can affect safety and compliance. If lighting and access-related integrations are disrupted, it can affect security operations and occupant safety during emergencies. Even in ordinary office buildings, causing widespread discomfort or triggering false alarms can create disruption, reputational harm, and costly response efforts. These impacts are why building automation security is not optional and why it belongs in the same risk management conversation as other OT environments. Another risk is that building automation systems can provide a foothold into broader networks if they are connected without strong segmentation. Attackers often look for less monitored systems as stepping stones, and building systems can be less monitored if organizations treat them as separate. Beginners should understand that risk is not only about what a system controls, but also about where it connects. A system that controls moderate impact functions but connects broadly can still create high overall risk due to lateral movement potential. Safe handling of building automation networks starts with visibility and inventory, because you cannot manage boundaries if you do not know what is connected and who supports it. Buildings often accumulate devices over time as renovations occur, tenants change, and new systems are added, and that can lead to forgotten controllers and segments. An inventory includes not only devices, but also network paths, remote access points, and management accounts, because those are often where risk concentrates. Documentation matters because building systems can be maintained by contractors who rotate, and knowledge can leave the organization if it is not captured. Segmentation is a major control because it limits how far an issue can spread, and it allows you to create a safer interaction pattern where building systems can share necessary data without being fully exposed. Access control is also central, especially for accounts that can change settings, and changes should be logged and reviewed because small configuration changes can have large effects. For mixed environments, it is often wise to treat the building automation zone as its own controlled area, with carefully governed interfaces to other OT segments and to enterprise systems. Beginners should see these controls as practical, not theoretical, because they reduce both accidental misconfigurations and intentional abuse. When a building network is well governed, it becomes predictable, and predictability is the friend of both security and safe operations. Another key idea is to respect the operational constraints of building systems when applying security measures, because disruption can create safety risks or critical service interruptions. Some building automation devices are older and may not handle aggressive scanning or frequent changes well, and some may have limited support for modern security agents. Patching and updates may require vendor support and planned windows, especially when the system controls critical environments. Remote access solutions may be necessary for vendor troubleshooting, but they should be designed with strong controls, like limiting access to specific systems, using time-bound access, and ensuring accountability. Beginners sometimes think that the best approach is to lock everything down immediately, but in facilities management, abrupt changes can create outages that are difficult to recover from. The better approach is deliberate improvement. Identify critical functions, protect the pathways to those functions, and reduce unnecessary connectivity while maintaining supportability. This is also where incident response planning matters, because if a building system becomes compromised or unstable, teams need a safe way to restore service without creating new risk. Building automation security succeeds when it becomes part of the facility's lifecycle rather than an afterthought applied only during crises. The exam mindset should be that you protect what matters while keeping the building running safely. A final beginner misconception worth addressing is the idea that building automation is just convenience, because many people only notice building systems when they are uncomfortable. In reality, buildings are part of critical infrastructure in many contexts, and their systems can support life safety, equipment protection, and mission operations. Another misconception is that because building systems are physical, they are isolated, when in reality they often connect to enterprise networks, vendor networks, and cloud services for management and analytics. A third misconception is that protocol names alone determine risk, but risk depends on deployment, including segmentation, access control, and how remote maintenance is handled. Even the best designed protocols can be deployed in insecure ways, and even older protocols can be operated safely when boundaries and procedures are strong. Beginners should also understand that mixed environments create more complexity, and complexity requires coordination across teams. When you see BACnet, KNX, and Profinet together, the key is not to panic, but to recognize that multiple systems are interacting and that safe operation depends on controlled interfaces. That recognition will help you choose safer actions in both study questions and real-world discussions. To close, handling building automation networks safely is about understanding that buildings are operational environments with real consequences, and that their communication standards enable valuable coordination but also create pathways that must be governed. BACnet supports interoperability and centralized monitoring for building systems. KNX supports distributed building control across many endpoints, and Profinet can appear in mixed environments where industrial automation components intersect with facilities systems. Mixed environments increase complexity, and complexity increases the need for clear responsibilities, careful segmentation, controlled remote access, and strong documentation. Building systems often have many devices and many physical access points, which means physical security and procedural discipline matter as much as network controls. When you reason about building automation security, focus on what the systems control, how they connect, and how changes are approved and monitored, because those factors determine risk more than the protocol names alone. If you can explain why building automation networks deserve serious security attention and how to manage them without disrupting critical services, you are thinking in the balanced, context-aware way that Security OT Plus is designed to measure.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BACnet.com.